is it clear? Now can you solve after this with stoichiometry? So what we will do in cross multiplication, I can say 1.5 mole O2. Okay, I am getting from 1 mole KClO3. Therefore, to get 30 upon 22.4 moles of O2, how many moles of KClO3 are required? And a cross multiplication will give you moles, and that moles to mass. Getting it? So your moles calculation will be here 30 upon 22.4 into 1.5, right? And you get moles, and from that moles you can use here, that will be moles of KClO3. You know molecular mass, weight will come. This method or that method, answer will be this only. Am I clear? Is this part clear to you? Either way, answer will come same. One by stoichiometry, another by POAC. Answer will come same. You work. Similar numbers are coming, answer will come same. It has to come same. Okay, so I am giving you 5 minutes mental break and we start after that. The lecture is up to 4, right? Cholo, sit down. So I'm giving last problem on POSCC, whether you can catch up. One more now for all those who are still struggling. Applying POSC, similar problem. This is very similar to what we have already done. You don't need. Read the problem. Not making you work more. How much is the answer coming, you said? 0.2. Maybe. Haven't written. Haven't written the answer. Obviously your carbon आना चाहिए, carbon 2. So similar to the first problem of POSC, you start with K2CO3. Some series of reactions are there. They say carbon is conserved. The shortcut here is, I'm not asking you mass, I'm asking you moles. So calculations have reduced. But we'll teach you how to apply POSC for all those who are still struggling and not understanding how to apply POSC. So because they say carbon is conserved, you will apply it to carbon. girls, see on the board. Tell me 1 mole K2CO3 is equal to how many moles of carbon? How many moles of carbon are there in 1 mole K2SO3? 1. So 1 mole K2SO3, 1 mole carbon. Now a complex compound is given, so I write 1 mole of whatever is this complex, K2, Zn2. We will learn this naming of these kind of complexes in a chapter of inorganic chemistry called coordination compound. After that you can write the name of this also. Okay, so 1 mole of this will have how many moles of carbon? Check carefully and tell me. 12 moles of carbon, not 6 now. As this whole bracket is also repeating twice. What is the meaning? Fe becomes 2 and Cn becomes 12 times. So carbon is 12 mole of carbon. So the whole POSC says whatever are the moles in KClO3 of carbon, same are the moles of carbon in this compound, right? That is what is POSC. So I will write number of moles of carbon in K2CO3 will be equal to number of moles of carbon K2 Zn2 FeCN6 twice. So that will be whatever are number of moles of K2CO3, same is carbon, or you can write multiply by 1. And here it will be 12 times moles of K2 Zn2 FeCN6 twice. Is it clear now? So what data is given to you? They give us a mass. From mass the moles will come. And into 12, and what we want is moles only. No mass here. Did you got it? So then after that mass is 27.6. We have calculated K2CO3 molar mass, right, in the previous problem. 138. Everybody knows 138 is the molar mass, equals to 12 into number of moles of the complex. So just get the answer for number of moles. Clear? Again he slept. Why he doesn't go home? Get up. You want to go home? You can go home. No problem. Sitting like this in the class has no meaning. Please go home. You're not even taking down what is happening on the board. So what is the answer coming? Understood the problem? So moles answer will be very less because see the molecular mass is huge here. क्या रहा है आंसर? 0.010, right? So is somebody calculating this? I'm waiting for the answer. 0.0166. So your number of moles, clear, around this. So see, that finishes stoichiometry and the variations in stoichiometry. The next and the almost last part of this chapter I'm starting. Then after that what remains are 4 laws. They are not important from IIT point of view. So this is the last part that I'm teaching in mole concept, but the important part, last but not the least. And after this, as I said, 4 laws are remaining. So now you check NCERT, everything is taught, stoichiometry over, but 4 laws are remaining. These 4 laws are very ancient laws given, which I will finish after I finish this. As from IIT part, that is not important, this is important. Now I'll give you a background, what is this, where we use, why we use and all that. I taught you when I started with mole concept, I told you why I am teaching you mole concept. Because when you practically have to carry out a reaction, you must know how much reactant you have to take to get a particular amount of product. Now any reaction given to you after stoichiometry and mole concept, if somebody says this much is the reactant we start with, you understand how much is the product form. Are you clear? So that job is done, right? You always know how much is the product form, how much is the reactant needed for a given reaction. That was the first aim. Now see, no talking. What is the second issue that will come now? Have you visited, have you seen ever a chemistry lab? So in chemistry lab, what you see mainly are some glass bottles and some liquids kept in that. Yes or no? So your HCl, NaOH, H2SO4, all these common chemicals, are they solid as a powder kept or they are kept as a solution? As a solution. So the next problem that comes in chemistry is, you understood mole concept, you understood stoichiometry. Now when you will go and take a bottle of HCl for some reaction or of H2SO4 for some reaction, okay, and done a reaction with you, see, I have to make you understand what problem you will face, then only you will understand what we are doing, not otherwise. So I have done this reaction with you. Aluminium plus sulfuric acid, this will give you Al2SO4 thrice. This will be 3 here, this will be 2 here, and I will get 3 moles of H2. We have already done this reaction. Now I ask you to do this reaction in the lab. Okay, we weigh 27 grams of, 56 grams of aluminium, which is 2 moles. Perfectly fine. Now stoichiometry says I want 3 moles of sulfuric acid to make it completely react. Everybody in the class understanding this. And you go in the lab and there is a sulfuric acid bottle, but on that it is written 10% W by V, a 5% V by V, or 2 molar. Then you are clueless how much from that bottle you need to add. How much from that bottle will make it 3 moles. Getting it? And this is the last part that I am teaching you. Okay, see here. So basically we handle some solutions in chemistry lab. So how the mole that we have already learned, we will apply to this is what we are checking. Now for that, I have to make you understand what is a solution first. As I am teaching you how to connect the two now, ultimately. So what is a solution, tell me, anybody in the class? Yes, it is a homogeneous mixture. So now we are only going to see the homogeneous things, not heterogeneous. And homogeneous mixture of what? Basically we say two components. No. Solute and solvent. So I have to make you understand what is solute, what is solvent. And here our idea is, so if I tell you कि I am having say ethyl alcohol in water, then you feel always ethyl alcohol will be solute and water is solvent. This is not the way. Or if I say salt and water, okay, usually salt should be solute and water should be solvent, but the definition is not this way. You always the one that is liquid is solvent and always the one that is solid is solute. The definition says out of the two components, whatever is present in smaller amount becomes a solute, whatever is present in larger amount becomes what? Solvent. Did you understood? So we say solution is a homogeneous mixture of solute and solvent, and solute will be always present in a lesser quantity, solvent will be always present in a more quantity. As far as chemistry lab is concerned, usually our solvent is water. Okay, clearly it's a liquid and that is water. That is all these acid solutions, alkali solutions that you see in the lab, they are aqueous solutions, AQ written. So what is aqueous solution? Solvent used for most of the cases in chemistry will be what? Water. Okay, if not, they will mention. If not mentioned, we have to assume it to be what? Water. Is this clear? And solute will be different solute. So is the solute solvent part clear to you? Now see, when in chemistry we have these kind of solutions prepared, okay, we must know, no, if I have to prepare a NaOH solution, NaOH is white color solid. Now see why solution is prepared and why I am not just taking a solid, weighing and adding. For a reason, when we are having in a solution form, rate of reaction increases. You'll understand it as we go ahead. Instead of making two solids react, okay, the rate of reaction is always more when we have a solvent. So to increase the rate of reaction that we are doing, we prepare a solution in water or in an appropriate solvent and we carry out the reaction. So it is more convenient to use, okay, and yes, because say HCl. HCl is not liquid only, if you know, it's a gas. Hydrogen chloride gas. Now I want to use a gas, it's very difficult. So for all convenience, we are converting it into what? Solution. Now when I am preparing a HCl solution or a NaOH solution, again same thing, can I randomly add some NaOH, some water? Then I lose my calculation part. So there has to be some systematic way of adding and preparing solution. And that is what I teach you in the last part. How these solutions are prepared, what are different ways of expressing concentrations of solution. And on the bottle that will be written. So if I am teaching you molarity and we prepare a molar solution, it will be written that way. If I am preparing a percent solution, it will be prepared that way and represented that way. And then based on that, I will teach you how to connect it to mole concept. Is it clear? So why are we doing last part? Because we are handling solutions in the lab. And we will carry out reactions with solution. Okay, so we must know how to connect stoichiometry to that. Am I clear? Okay, so it's very simple part comparatively. You ask me what we will be doing now is a very simple part. There are 5-6 ways of expressing concentration of solution which I am teaching you, And this is like a school chemistry, a formula comes and you straight away substitute in the formula and you keep getting the answer. No headache as far as basic concentrations are clear. Okay? So there are various ways of expressing concentration of solution. First way is percent concentration. So now I'll explain you what is percent calculation. Now see, whenever we use the term percent, मतलब क्या लिखा मैंने? Constant बराबर है? You are confused. Percent concentrations we are doing. Now see how to prepare this. It is always will be with respect to 100, right? So I'll teach you how to prepare also in the lab and what are the formulas also. First method is mass percent. And for mass percent, we represent this as W by W percent. What is the formula of mass percent? Simply mass of solute upon mass of solution into 100, and this will give you mass percent. This is the formula. But I want you to understand how actually it works, how to prepare and everything behind it. Okay, by taking an example. So suppose I want to prepare 20% NaOH solution in the lab. So tell me, what is solute, what is solvent for this? You tell me. Solvent is water, all solutions in water. And solute is NaOH, sodium hydroxide. All clear till here? Okay. So at the place of mass of solute, mass of NaOH should come. At the place of mass of solution, what should come? Total NaOH plus water together. Because solution is equal to solute plus solvent. So that what should come is a total mass and multiply by 100. How do we prepare? So basically there, I want this answer to be 20. Are you understanding? My result is 20%. Yes or no? So simplest way to make you understand is, I take a mass of solution 100, and how much should be mass of solute? 20 grams. Are you understanding? So if I take 20 grams of solute upon 100 grams as a mass of solution, my solution will be 20%. Is it clear? How do I do it in the lab? I am explaining you that as well. So here we start with a conical flask or a flask like this. Okay, and we have balance. So I'll keep an empty flask on a balance. I'll get a mass of a balance. I make it 0. And then to that, I'm going to weigh first NaOH. And this will be 20 grams NaOH. Is it clear? And then I keep it on the balance only, and I will go on adding water till the total becomes how much? 100. So when I am writing this 100, I know that and I can add masses. My mass of solute is 20, NaOH 20, and water is undoubtedly 80. Because mass can be added. What you can't add is volume. You can add mass this way. Is it clear here? Okay. So meaning is, I'm keeping this on a balance and I will go on adding water. Okay. And the mass of water is 80 grams water. And together now I am having 100 ml NaOH solution in the flask. Now I am writing 100 ml. I should write 100 grams here. Let me not confuse you with ml right now. I am writing 100 grams. Is it clear till here? It is on a balance right now. So this is a 100 grams NaOH solution. Clear? Now what shall I put a label on the bottle? 20%. Okay, 20 grams in 100 ml. For all the calculation, we know that how much is NaOH taken, what is the ratio with water, everything. So from that we can reduce to mole and do the calculation later. Did you understood? Now what is the whole meaning of W by W here? W by W is, here we take weight of solute upon weight of solution, both W. Now next will be W by V. Now why V? Because in chemistry, the liquid we prefer measuring in ml and solid we prefer measuring as a mass. Okay, so when W by V is written, understand method changes. This is not how I will be preparing. I won't be preparing by keeping it on a balance. Okay, I do keep it on a balance for something, but then I will take something as volume. Okay, so there are various ways. First percent W by W, everybody understood what it is. Now second is, so can we go to the next page? You want to copy something, please copy, otherwise I am taking you to the next page. And this kind when I am preparing, this is undoubtedly W by W. I am weighing. So whenever a percent is given, for any calculation, look what is written in a bracket. It is W by W, W by V or whatever. That part is more important for further calculation. Now next is, we are in mass percent only, percent concentration only. But next is volume percent, B part. This is volume percent, and volume percent will be written as V by V. Now what kind of a solution I can prepare by this method? My solvent is liquid and my solute is also liquid, both liquid. Then this method is preferred. Getting it? So what will be the formula? It will be volume of solute upon volume of solution in 200. Formula remains similar. So see, these formulas you don't have to by heart. They are all similar. Now can I prepare, my question to you is, can I prepare 20% NaOH by this? No. Because NaOH is a solid and I cannot measure it in terms of volume. See, this is the practical details I am teaching you. Pay attention, otherwise you won't understand the language of the problem. See, your problem comes with a particular language. So NaOH, this doesn't work. As NaOH is a solid, white color solid. Okay, you understand, when you measure in ml, there has to be a liquid, at least, if not burette pipette, everybody has seen a dropper. Now can I take with a dropper a white color powder? No, the white color powder can't be measured with a dropper, understanding? So this method doesn't work if I have to prepare 20% solution of NaOH. But I will give you example. I am preparing say 25% ethyl alcohol solution, aqueous solution. Okay, AQ written means my solvent is water. And what is my solute? Ethyl alcohol. How do I do it? I am teaching you that. Now here answer is 25 and simplest way to solve is this. So how much is the volume of solute I need? 25 ml. Now no grams, this is 25 ml. How much is the volume of solution I need? 100 ml. How do we do it? There is something called as pipette. So what is a pipette? I'm not drawing pipette, I'm drawing something else. Pipette is a long syringe, you can say. A syringe but which is long. So from which I can use a bulb like what syringe has. It can be 10 ml pipette, 20 ml pipette, 5 ml pipette, and from that I can pipette out like a syringe. You will take 25 ml of ethyl alcohol. Did you got it? A bigger syringe is called as pipette. So from that I take 25 ml of ethyl alcohol, but in a flask. This flask is calibrated, has a marking here of 100 ml. These kind of flasks in chemistry lab are called measuring cylinder, or more appropriately, instead of measuring cylinder we say dilution flask. Use that term only for solutions, dilution flask. And then in the lab you will have a 100 ml flask, you will have a 500 ml flask, you will have a 1000 ml flask. All flasks are there with a clear marking. You add a liquid here, and if it reaches here it will be 100 ml. So in this what I do is I will first take 25 ml from the pipette. And then I will go on adding water till the level reaches this. Did you understood how it is prepared? Now here, and make a note of this and write why I did this way, because volume is not additive. What is the whole meaning? I can't say this has 75 ml water, and you will get a more clarity about it in a devoted chapter called solutions. For some, 25 plus 75 if you add, it can be little less than 100, and for some it can be little more than 100, and for some it will be equal to 100. Three cases we get in solution. Okay, some when you add, okay, their volume, net volume at the end is little less. For some it is little more, and for some it is same. So I cannot generalize that like mass 100 gram 80 plus 20. I cannot say 25 plus 75. That's the whole reason I never took 75 and added. What I said, take 25 and go on mixing till it becomes 100. So whatever it takes to become 100. Am I clear? So I gave you formula that you know. I told you how to prepare. I want you to write one note there. And this note will be for things in future. Volume is not additive is the note. You can add mass. If a mass of solution is given and solute given, you know mass of solvent if it is mass. Not here. Volume is not additive. Am I clear? Additive. You cannot add two volumes. It is not additive. See, if I have to define this, what is percent by volume? Percent by volume is mass of solute dissolved in 100 ml of solution. What will be percent of weight? Mass of solute dissolved in 100 grams of solution. Getting it? W by W will be in 100 grams of solution, and V by V will be in 100 ml of solution. That's the only difference. Do you understand? Now the third category, third case in percent is mass by volume, W by V. And this is most preferred in chemistry. As usually our solutes are solids and our solvents are liquids. So we prefer this mass by volume. How do I represent this? W by V. What will be the formula? It will be mass of solute upon volume of solution into 100. Is this clear? So can I prepare ethyl alcohol solution by this now? Yes. I can weigh ethyl alcohol. What is the problem? But I can prepare also NaOH by this. Are you getting it? How do I do it? Same flask. See here. I will keep it first on a balance. I will keep this on a balance. And suppose I want to prepare 10% NaOH. So I am preparing now 10% NaOH. Which way? W by V. This will be given because you understand anything changes there, method changes, everything changes. So W by V means weight for solute and volume for solution. So here I will take for 10 grams by properly weighing 10 gram NaOH. And then I will in a flask, I weigh that. And then I take it out from the balance and I go on adding water till it becomes 100. So what is the mass of solute now in my case? 10 grams. And what is the volume of solution? 100 ml into 100. Getting it? And this is what will become 10% W by V. Did you got it? And this also has an alternate name. This is called strength of solution. Only when we express it in grams per ml. Strength of solution in grams per ml. So when I write the two units like this, you understand the solute is in grams and the volume is in ml. This is W by V. So whenever we are saying strength of solution in any problem, by definition it is W by V. To nothing else we call strength. If this is strength, means W by V given. Did you got it? So this will be obviously equal to mass of solute in grams upon volume of solution in ml. Now you will say, what if we take in liters, what if we take in kilograms? Then you have to convert and put it in grams when strength is asked. I have given you the conversions. Any other unit you need to convert. If it is strength, express it in grams per ml. Am I clear? By doing appropriate conversions. So is this clear till here? Okay. And we are still in percent. First method. Two more methods there. No, no, I'm out. I said 6, 7 methods. Okay, not 4. And 6, 7, I'm in the first one only. I'm showing you the cases in first one. Yeah, I think ICSE, IGCSE has all this in 10 standards. CBSE, once upon a time, believe me, in early 2000s and all, CBSE was very comprehensive. All this that I'm teaching you was a part of 10 CBSE. Believe me or not, yes. But after 2005, they went on diluting that CBSE book, and today it is highly diluted. Doesn't have a content. ICSE was always there way back, but number of schools were less. As CBSE started diluting, people started shifting to ICSE. This is what has happened. As CBSE, the content was diluted, ICSE didn't dilute. But once upon a time, they were almost parallel, and I will say CBSE was higher than ICSE. Yes. Chalo, can we go ahead? So see, in the same sequence, I am giving you this next definition. I'll make you understand the meaning also. So up to now, when I was talking percent, my solution was 100. 1% means 1 part of 100. Yes or no? Everybody agree when we say percent and I have a 1% solution, then whatever is my solute, that is 1 part in 100. Now next, you might have heard it. I'm not sure whether you have used it in calculation till 10 standard. Is parts per million. So what is the whole meaning? Why we need something like this? I'll explain you. Now say air pollutants. If you see any news and they are talking or giving you a pollution news, the pollutants are always given in ppm. Why? Because percent is a too large unit for them. Okay, if I divide air into 100 parts, the pollutant is not one part of it, very less part of it. So ppm, or say, our tap water that comes, okay, it is chlorinated coming, right? A chlorine is treated. So how much is the chlorine in that tap water? I can't use percent because it is very, very less than 1%. So percent becomes too large for few studies. So we need a smaller unit. The way gram was too large unit to measure weight of atom, so AMU was designed. Exactly in the same way, percent is too large for so many things. So ppm and ppb is designed. What is ppb? Parts per billion. So what is the definition? One part in million of a solution. So if I divide the solution into million parts, one part of it. And what is percent? If I divide the same thing into 100 part, one part of it. So everybody understand 1 ppm is always something very, very tiny to 1%. Okay, method is same. Calculation method is same. For million 10 raised to 6 will come and billion 10 raised to 9 will come as a factor. Okay, so concept wise same as percent, but these are the smaller unit designed to measure something that is present in very trace amount, or when any radiation leak happens. So that is in ppb, it goes in ppb. Percent is too large for that. Are you getting it? So I'm just giving you formula for ppm and ppb. Now see till here the formula remains same. When it was percent, we multiplied by 100. As it was out of 100 a part that we are counting. Now I'll multiply by million because I'm counting a part out of million. Did you got it? 10 raised to 6. You want to write a definition. It is the amount of solute present or amount of solute dissolved in 1 millionth part of a solution. This is what is the definition. And similar is parts per billion. So your PPB will be equal to exactly same thing that I'm writing. Mass of solute upon mass of solution into 10 raised to 9. And what I'm not giving is, when I'm writing this formula, it is W by W. Now this also can be V by V, W by V. Your PPB also can be W by W, V by V, W by V. I understand that you are smart enough to change and do it. So everything here is further divided, which I assume you can understand and you will do it. Yeah, you can have parts per trillion and so on. And so yes, IIT, you need to know all this. I gave you million, billion, and if the question comes in trillion, you know how to design your own formula and solve. This is what is needed. This is what is needed, bacha, for IIT. Your teacher cannot cover everything. Teacher is trying to cover and show you the path how to go. If they come up with a new number, then you have to design your formula and solve. Yes? So what will be the... Yes, 12. No, no. Units can be, but they can see today we are global, right? We are using Google. Do we have an Indian system to replace Google? Then we talk Indian. We are using Google. Everything is coming from US. We are talking million and billion every day, right? Yes or no? So we are not using lakh and crore. We don't use, even in the currency, financial, they are talking everything in million and billion. Nobody uses lakhs and crores. So you Google and check and expand your knowledge after this. I've taken you till billion. Can I go ahead? Bacha, there is no end to it. No end to it. You must have general knowledge in every thread. If pound is coming, when I do the mass, I'll give the conversions. Can we go ahead? So see, today I'm just giving you formulas basic. Next lecture, I give you numericals based on this. I'm just giving you formulas today. So is this first method clear to you? See the second method. Or to make you feel good. I'm just making you feel good. First method was mass percent. You can count it separate. So not one, we have covered three. You'll feel good. No, three we have covered. Yes, now the fourth one. Now this is very important. We keep using this again and again. Called mole fraction. this will be very simple for you to understand now. See on the board, I define mole fraction, and understand anything which says fraction, total is 1. All the components, mole fraction I add, total will be 1. All the components, percent I add, total will be 100. Are you getting it? So when percent is used, total should be 100. Fraction is used, total should be 1. So I am just taking a solution of two components A plus B. Pay attention on the board. Okay, there are two components. Any one will be solute in that, and the next one is solvent. Two things I am mixing. I am explaining you in general now. So two components are there, A plus B. We are forming a solution. So let XA be the mole fraction of A and XB be the mole fraction of B. Is it clear? I am just defining the terms with you. So see, how do I calculate mole fraction of A? The definition says number of moles of given component to total. Meaning is, my mole fraction of A is number of moles of A. No talking in the class. We are very slow, we have to speed up. I am unable to speed up in your batch due to disturbance. Is this clear? The definition is clear. Number of moles of given component upon total moles. So tell me, what will be the formula for XB? Can you write the formula for XB? Is everybody able to write the formula? It will be number of moles of B upon total moles, Na plus Nb. So this is what is mole fraction. Number of moles of given component upon total moles. Basic formulas on the board. Now suppose some other data is given, then I can calculate number of moles by weight of B upon molecular mass of B, and number of moles of A as weight of A upon molecular mass of A plus weight of B upon molecular mass of B. Is it clear? And similar way, I can write the formula up. So all this is now easy to understood because we have understood moles. Am I clear? Now I am giving you two relations finally. So you have two formulas. Always the total of mole fraction will be 1. The total will be 1. And always the ratio of mole fraction will be the ratio of number of moles, right? Everybody understands? थक गए थक गए. So I'm not teaching the next method, but mole fraction, one problem I'm solving, and that's it for today. I've given a formula, so at least one problem we must solve. Okay, and percent and ppm and ppb all tomorrow. A simple problem on mole concept we are solving. So take down the problem, formulas on the board. 23 grams of 23 grams of, you're still writing, finish it up. This only, na? 23 grams of ethyl alcohol, 23 grams of ethyl alcohol is dissolved in 90 grams of water. 23 grams of ethyl alcohol is dissolved in 93 grams of water. Calculate 90 90 grams of water. Calculate the mole fraction. Calculate the mole fraction of ethyl alcohol in the given solution. Ethyl. And believe me, it's the simplest possible problem. Formulas on the board. I can't give you anything more simple end of the day. You have physics doubt class, right? So yesterday there was some confusion about the doubt class. Understand what is a doubt class kept. You have classes, right? Doubt class is if you have some doubt. You ask whatever teacher given, you go and ask that teacher. Doubt class, nobody, like usually we don't do it in a class because whatever is his doubt and her doubt won't be same. So making her sit for his doubt is not correct. Okay, so doubt class is individual. You can go talk to your teacher, get your own doubt solved. And if you don't have a doubt, you can go home. As simple as that. So it's up to you. That I don't know. He will decide. He wants to teach you, I don't know. For my, I have defined my doubt classes will be this way. So you have a doubt, come to me. I'll be sitting maybe in the class down, wherever, and you can get it solved from me. I won't be teaching in a doubt class. Now, if sir wants to, he may teach. I have no idea. If he has asked you to sit in the class, then sit in the class. So I want to calculate. I am solving here. What is given in the problem? Mass of ethyl alcohol given. How much I gave? How many grams? Okay. And what is given? Water. 90 grams. And what is asked? Mole fraction of ethyl alcohol is asked. Can you solve now? So what will be the formula to calculate mole fraction of ethyl alcohol? It will be number of moles of ethyl alcohol plus number of moles of water, and that's it. usually can't solve mole concept problem, those people can solve this. All those who find stoichiometry difficult, they can do this. If little bit understanding is there. तो क्या मतलब story काम कर work no. I'm wondering which college will take you for engineering. Where you will go? Yeah, you need to start your own college in your backyard. So what is the molecular mass of ethyl alcohol? 2 carbon, 6 oxygen. Sorry, 6 hydrogen, 1 oxygen. 24 plus 46. So number of moles will be 23 upon 46. And here 23 upon 46 plus 90 upon 18. And see how simple numbers I have given you. To that I say curated problem. Right? Yes. So what is 1 by 11 equals to in fraction? So this is nothing but 1 by 11. And 1 by 11 will be equal to how much? 0.099. Correct. Yeah, 0.9 will come. Yeah, we can just do it up to second decimal. That's it, right? Chalo, that's it for today. All those who need a worksheet can take it from the office. Chemistry worksheet. It is important, very, very important.
So you are saying something in the beginning like it is needed for IIT but not so important.
That is the laws that are pending. This is, I had put
This is
3
important.
stars.
Okay.
3 stars and I started.
I saw. I couldn't see from there, so that's why I had a
I had